Okay. Hello, Ajay. Am I audible?
Yes, sir.
Okay. So we'll continue. So where we left in the last class, from where we left in the last class, we continue afterwards, like looking at what is DIGRP. So in the last class, we discussed about OSPF, right? So and also some of the terminologies, so which would be used as an advanced concept in OSPF. So that is also we just looked at in previous class, right? So we would understand what is called different types of areas in OSPF. We called some areas as stub area and totally stub, NSSA and totally NSSA. Okay. So today now we were looking at another one, which even is widely used in intra-AS routing protocol, which is EIGRP. Okay. So this is actually an advanced version of IGRP. Okay. So this protocol this is also what you call here itself you can see. So earlier we used to call it as IGRP, and there is a modification in this protocol. So now we would call it as IGRP, and no more we use that IGRP in today's any network. Okay, so most of the time we use this EIGRP. So we are not going to use IGRP anymore because so it has its some disadvantages in IGRP. So that's why we have a modified version of that, and we call that as enhanced interior gateway routing protocol. And we should have an understanding about comparison between what is this so EHRP and OSPF, because when we have a multiple things, then obviously you should compare each one of them, and we have to understand what is an advantage of each one of them, right? If you go any shop or any purchasing something, so if you find the same thing, you like to purchase a mobile or something, and you just said everything. I need 4 GB of RAM and 256 GB of ROM. So then you will see the same configuration. With the same configuration, you will see different brands of mobiles, right? So then obviously you will go for comparison between them. If you have multiple options to select, okay, you just compare them. Once you compared, and then you will go with among them which is the best for that, which is best, then that will be you will be selected, and then that will be buy, right? Something when we have multiple options, so in any of the things if you take, so we'll look at understand each one of them by its advantages and the disadvantages, and and we'll understand, and also we use the respective routing protocol based on the scenario, based on your network. Okay, that's what I could say here. So having these three as an intra AS, so intra AS, you guys have known, right? Intra AS something within an autonomous system. So if I call this as one autonomous system, so we use that routing protocol to exchange the route within the autonomous system. It doesn't go outside this autonomous systems. Okay, so so we have three options here. One is RIP, and another one is CHRP, and another one is OSPF. Okay, so very simple. If you look at one side, so your RIP is very simple and it doesn't have much advantages. And if you look at that protocol, it much has a disadvantages itself, right? So if you look at these two, so what is EHRP and an OSPF? So where you could see some advantages over in EHRP, and that would not be there in an OSPF. Okay, so what the advantages we have in OSPF will not be there in AHRP, or what the advantages we have in AHRP may not be there in OSPF. Okay, so then why we need to understand, why we need to study this protocol, okay, which is CHRP. Okay, so this is interior gateway. I think you would understand interior gateway means within an autonomous system we use this routing protocol. Okay, So the very first, after you understanding this OSPF, so the point one thing you understood there, it's not very simple, right? So it's more complex. I think we must have something called this design rules have to kept in mind before you're going to configure that OSPF on a given network, right? So we should know the how many areas I must take, and every area must connect it to a backbone area, and we know something. In order to optimizing this, we should know which area I could call it as stub or totally stub in order to optimize the inter-area routes or external routes. But that is not the thing in EIGRP. Okay, it's only one route, so it is called EIGRP routes. So within an autonomous system. Okay, so we would said like when I understanding this OSPF, so we said like it supports unlimited outcomes. Okay, so whereas in RIP it only supports 16 outcomes, where in OSPF I said it supports an unlimited outcome, right? So, but in EHRB, it's going to support an outcomes of 255. Okay, and even if you think if you look at any organization network, it's not going to be more than 255. Okay, so in your CCNA course itself, I have told, okay, in an internet, if you want to reach from your source to any other destination, it maximum of the outcomes is going to be 8. Okay, so so that if you have that idea, so then even if in your internal network it's not going to more than into 55 outcomes, then you can think of using EHRP would be better in your organization for the configuration. Okay, so if I look at here some of the aspects where we should look at, so to compare these two from the perspective of the algorithm and the CPU usage, the convergence time, and the design aspects, and something scalable and the service provider support. Okay, and there is something a unique feature we would having, so we will be having in your EHRP is unequal cost load balancing. Okay, if you take all these three, which is even if I include RIP, it default it supports what is called equal cost load balancing. Okay, so it default it supports equal cost load balancing, and but we have one unique feature which is in EHRP, it supports unequal cost load balancing. So what do you mean by equal cost load balancing? Okay, let's take an example like have a network like this. Okay, and this is your destination network. Let us say network D, and this is your source network called as S, and I just named these routers A, B, C. Okay, if this is a network, this is your LAN, source LAN network, means your source is lies here, and your destination is lies in this network. Okay, so if I use a RIP, okay, what is the best route from source to destination according to RIP? It based on what? Hop counts, hop values, right? It takes an hop counts to select the best route. So what is the hop counts here? See, from source you could go to reach a destination in two paths. One is AB, the route via A this way, and another way you could go here. It is A comma C. Okay, and both as the outcomes as one, right? So this is a one outcome, and another is this is another outcome. Okay, so one, but you cannot say this would also be in one outcome because it is not a router, it is where this router is directly connected to the destination, right? So where these two routers are connected to a destination, so this should not be considered as an outcome. Okay, so it's just like a distance between one router to another router, we call it as one house. Okay, so if that is the case, so if you see this router can send the packets in two ways, so or in AB route or in AC route, but the cost of that is same. So then what this routing protocol RIP will does, it does something called load balancing. Okay, so in this scenario, if you ping from this source to a destination, so ping we know that it's going to send a 4 packets, right? A simply dummy 4 packets to check whether the destination is alive or which is connected in a network or not, right? It send a 4 packets. When that packets comes here, so first it's going to send a package for here in this route, and the next packet will be forwarded over here. Okay, means I mean to say if source sends a 4 packets, so the 2 packets will go from this route and another 2 packets will go from this route to a destination. Because so that is what the default behavior of this RAP means. If the cost is same, okay, if the cost is same for a routes, okay, to a destination to specific network, then it do load balancing. Okay, the traffic will load balanced. Load balanced means the number of packet that what you generate or what you send, that will be means separated, and that will be sent through a different routes. So which has some equal cost. Okay. The same thing we would also you can think of in OSPF. If you would also have something in equal cost more than one route, it is also do the load balancing. Even in AHRP, it is also do load balancing. If and only if the cost of the routes are equal. Okay, so one and one. So you can think of in OEA this one. Uh, so in OSPF, so we know that it takes bandwidth as a count, right? So you can think of all the links would be having a same bandwidth. If I use here a fast Ethernet, so we know that the bandwidth of that is 100 Mbps. Okay, so 100 Mbps, 100 Mbps, 100 Mbps, 100 Mbps. So obviously the cost is equal. Then again that OSPF also do load balancing. So in EHRP, so we know that something the cost, the metric we calculate the cost is bandwidth plus delay. Okay, so the bandwidth, so we know that bandwidth, right? So the bandwidth of that link plus the delay associated with that link. So delay associated with that link means if you have a link here, if I placed 1 bit on that link, what is the amount of time it takes to come out from that link? So that is what we call delay. So okay, it depends on the propagation delay and the distance. Okay, we used to measure them with microsecond in terms of microseconds here. Okay, so that you could change it. Okay, so that these 2 parameters you can change. Okay, so the bandwidth of it you can limit it, and you can change the data as well. Is something. So if your link is having 100 Mbps and from your service provider you get the internet for some 10 kbps or 10 mbps. Okay, where this limitation of this 10 mbps has been set by this service provider. So you want to have a bandwidth of 100, but your service provider limited your bandwidth to 10 mbps. That's what the tariff that you have taken. Something like that. These two things, parameters that you can change. Obviously, the cost of the link would be also changed. Okay, so if the cost of the links or the metric of any routes is the same, then even in the HRP it supports the load balancing. Okay, but the thing is here you can see it even also supports unequal cost load balancing. What do you mean by unequal cost load balancing? Can anyone tell? So can anyone tell what is unequal cost load balancing? So I just said equal cost load balancing means if the cost of the routes are same and it send the load balancing, it means that packet will be sent on every route. So what do you mean by unequal cost load balancing? Can anyone? Sharon?
Hello, sir. Sir,
Yeah.
even if the both the cost of both the paths is the same, it will not be equally divided. The traffic will be not equally divided among both the parties.
Okay, okay. That is not the thing. Okay, I will explain you it. Okay, unequal cost load balancing means if you have a multiple routes to reach a destination, okay, to proper destination. Let us take this is your network. Okay, uh, this is your destination, and okay, this is the network. Okay, and this is your source, and this is your destination network. So, according to RIP, what is the cost of this? It is one of from A to B, and we have C something, and we have D here, and is your network called E. Okay, so we have two routes, but the cost of this is not same according to RIP, right? So RIP, if I take a routing protocol, the cost is here one hop, but here it is two hops. Okay, then obviously it will choose this routes for the forwarding the packet. Okay, in RIP. But if I take an OSPF, again the cost would be here it is less as we compare with this. Okay, so then obviously this will be chosen as best route. And this route will not at all chosen for the forwarding a packet. So we have even still to forward a packet. So we have a path to forward a packet to carry out this packet. But this default behavior of this protocol will doesn't support, means it doesn't forward any of the packet over here. But in EHRP, we have something called unequal cost load balancing. Okay, even if you look at here, according to EHRP also, this will be the best route because the cost will be very less. Bandwidth, because of if whatever the link we have in this complete network having a same bandwidth and the same delay, if you assume, probably this would be the best route according to EHRP also. Okay, so what we can do here, so it will not do load balancing if if it is not an equal cost. So that should be manually enabled by a network administrator. Okay, means it is a feature in an EHRP where you can still load balance the traffic over this route as well as this route. So means with all possible routes, whatever the possible routes we have from a source to destination, even though if they are not, uh, all of them are not a best route, even we can still send a packet over all possible routes. So that is what we call so unequal cost load balancing. Means the cost is not same. So then we would still you can send a packet on the both the routes. Okay. So probably then you can ask like, sir, if we do like that, okay, the time at which this packet arrives will be more, and this packet will be get delayed, isn't it? So that kind of question that you may have, but we know that the OSI model, unless or until sequence order packet will not receive, that will not send that packet to an upper layer, right? We'll keep waiting for that packet. Once it's arrived, so it will combine it and recombine, reassemble, and it will forward it to an upper layer. So that is the function of the transport layer, right? So we do something called segmentation and reassembling the transport layer. So, so that it's a deal of milliseconds. Okay, if this would comes arise first, probably this would comes within the next 30 milliseconds or something. So that up to that time, that buffer has to wait to get that packet. Once that comes, then it is reassembled and it will give on to the upper layer for the process. Okay. Okay. So that is the thing. So that's what here they're written. Okay, then you can simply go over here. So whether working on ring topology, so this would not be good. Where OSPF will be better. Okay, so why we this would not good at ring topology, because it creates a loop. So we know that, right? Ring is something, everything is connected one another, which forms a circular ring, right? So in that scenario, this will not be good because it creates a loop and unnecessary broadcasting will be taken place and more congestion in the network. But where that would be very good at in OSPF. So we divide, even though if you have a ring, so we'll form them from each like device into different areas. So then that will not be a problem in OSPF. It's okay. So and there is something called hub and spoke method. so which is very poor in OSPF, but it's very work well in AGRP. Hub and spoke is something we used in VPN concept. Okay, so we used to configure the devices like how one device would be in hub and another spokes. Is something like master and slave kind of configuration. So where in OSPF it's very poor, but in AGRP it's very well. So both will suit for the WAN connection, and for data center network we use most of the OSPF compared to AGRP, and both of them are support MPLS network. So, and standard protocol. Okay, so this would be standard and open standard, but this is not, because it's earlierly it's an open standard. It's not an open standard, but is now AGRP would also be open standard. Okay. Okay, so then this would be suitable for service provider IGP. Yes, no. Complexity, we know that OSPF is more complex because it process itself is very complex. It has 7 states, something we understood. But here in AHRP, it's very simple. It's just in 3 state, 3 steps, which forms a neighbor relationship. So the default convergence time, you could say, so if by comparing these two, I would say OSPF has slow convergence and in EHRP has a faster convergence. So that means that, so, so, so what I can say here, in OSPF, we have something called database, right? So database used to keep all possible routes to every remote networks. Okay, but in EHRP we have something called topology table. In this topology table, instead of keeping all possible, all the routes to a possible, sorry, all possible routes to a specific remote network. So instead of that, in EHRP, what we will do? So among this, the best route will be chosen and will be kept in the topology table. So in OSPF, we have 3 tables. One is called neighbor table, and one is called database table, and another one is called routing table. So the routing tables, we know that it's the last and final table which containing the best route to each and every networks. But the database table, it is something all other possible routes to every remote network. Okay, it keeps the complete database of the complete domain. Okay, so then the neighbor table, you will get something, the information about the neighbors. Okay, if this is something connected like this, so every neighbor information you will get it in neighbor table. Okay, so we have 3 tables in OSPF. One is neighbor table, database table, and routing table. So routing table is common, right? It's common to every routing protocol. But database table is something keeps every other possible routes to every other remote networks. Okay. So the same thing in EHRP, we will be having 3 tables. One is neighbor table, and instead of database table, we have something called topology table. Okay, topology table, the changes here, instead of keep the every possible routes to a remote network, instead of all possible routes, with this all possible route, which is the best route, I will keep that only route in my topology table. Okay, as a secondary path. Okay, so the primary path will be kept in routing table. So if that path is not, it's not ready, or it is not no more there, then it will take the secondary path, which is stored or kept in topology table automatically. So and similarly, we have the neighbor table in the EHRP also to check who are the neighbors to each router. Okay, is that clear? Any doubts
No, sir.
from others except Karthik? Rahul Rajkumar. Okay, so So coming back to the configuration and so the implementation of this AHRP. Uh, so in the last class, I just did this OSPF, right? To understand this stub and totally stub concept. So here, by taking the same thing, I'm just implementing this EHRP. So the last for B section yesterday, I did this one. So this the partial network which I have circled here, which I mentioned here, area 10. So I just removed that OSPF and I configured this with an EHRP. Even you can verify it. So to verify, so which routing protocol is running, you just give a command like show IP protocol. Okay, just you should give the IP protocol. Here you can see EHRP is running, EHRP 11. Okay, and this for the network address which is advertised with this protocol, and the gateway is this, and the distance AD value is 90, and the last update is this. Okay, again there is something called internal and external, so we will not worrying about it right now. So we'll discuss that later. And something you would see here, some k values. So the Cisco, they have mentioned these parameters which is taken to calculate a cost with these k values. Okay, so actually it has five metrics. One is so five parameters to calculate a cost or a metric weight. So it is something, it takes bandwidth, delay, load, MTU, and reliability. So each one of these parameters is given with this k notation. Okay, if I take bandwidth, so we call them as k1. Okay, then if I take load, that would be given with k2, and delay we would given with k3, and MTU is given with k4, and reliability is given with k5. For each parameter, the Cisco, they have given a standard k values, which is k1, k2, k3, k3, k4, and all of them are not used to find the cost, because if I look at this load and MTU and reliability, this would keep change. These parameters would keep change for every second. So that makes an overhead on in routers, right? Because if that would keep changing every time, so the router itself has to keep doing this calculation and running this dual algorithm or HRP routing protocol algorithm to find the best path. Okay, since this would keep changing every time, so your protocol will not be inefficient, right? It means it doesn't do any other things. Instead, you just keep on calculating every time as the load, as the MTU, as the reliability is changed. Okay, so that's why. So we made that parameters equals to 0. Means we are not taking that parameters for the consideration. Okay, we just take k1, your bandwidth, and the delay. Okay, that it doesn't change oftenly, right? The bandwidth doesn't change. Once you fix the bandwidth, so that is fixed. All right, then when you change it manually, then only the bandwidth will change. Then again, this process has to be taken place, and even the delay would also not change. Okay, since we know the bandwidth and we know the distance and all, so the delay would also not change. Okay, so that things that you would also verify here, something show interface gigabit 0/0/0. So when I getting some information about that interface or something, that line port what I said, so here you can see this would be the MAC address. Okay, the MAC address. Okay, and what is the IP address which is assigned to that. And here you could see some more information that which are required for this EHRP to calculate the cost, right? So we need something called MTU, so maximum transmission unit, and we know that in Ethernet the maximum transmission unit is equals to 1500 bytes. It should not be more than that. So the data should be, the payload of length should be 1500 bytes, and adding 18 bytes of HORIX or overheader. And here you can see, so why this would be something 1 lakh or more than 1 lakh, I think. So 1 GB. So 1 GB, because here you can see, so this is a gigabit Ethernet. So gigabit Ethernet, the bandwidth is obviously 1 GB. So the bandwidth is 1 GB. Okay, and also you can see the delay is 10 microseconds. So I said right, it's a 10 microsecond delay. So and the reliability, okay, the reliability is something how you measure. We measure the reliability in terms of numbers, integers. Okay, so from 1 to 255. More the value, more the reliability. Less the value, less reliability. Means if I send 100 packets on this link, the reliability will be measured in terms of these numbers. Okay. So if I get a 255, means the reliability is 100%. Means if I put 100 packets, every 100 packet will reach the other end of that interface. Okay. So if it is say 254 or something, you would say there is some loss of packets in this link. Okay, so that the way you could think of what you mean by reliability. And similarly, we would be having something load, something TX load and RX load, transmission load and receiving load. And this would also measure with some number. So less the number, less the load, more the number, more the load. And we use an encapsulation. Loopback is not set, and full duplex, and the channel mode is full duplex. Both the way we would transmit simultaneously, and RJ media type you can get, and so all this information you would be able to get in this interface. Okay, is that clear?
Yes, sir. Sir, I had one doubt. I asked in the lab, sir, how to configure that loopback address.
Yeah, I will show you that now. Okay, so just loopback address. So why I used here. So the loopback address. We don't want to use this loopback address, but we would be using if I want to build a network which is 30 dot network. I need a switch and some devices where I used to assign this IP address to each one of them, and doing all these things. It's again consuming a space in this workspace. And okay, so what I could say, so I'm just assuming this LAN, a local area network, and that network which is having an IP address with this 30.0.0./8. Okay, you can create that as within one virtual loopback interface. Okay, so I just assign an IP address from this network address, which is 30.0.0.1/8, and I call that as a loopback. So loopback is something virtual interface you can think of. Okay, so that's where we use, and it is not the way. That is not the only reason we using here. It adds some other reason also, because the loopback interface never comes down. Okay, it never comes down means it is created virtually, right? So it doesn't affect unless or until the software on the device will crash. Okay, still that virtual link will always be up. But physical links, what will happen sometime? So someone will unplug the wire or something is happened. They may cause to down on that router. Okay, that's why what we do, we use something called loopback address. I will tell you this later, I think. Or so whatever we do in the neighbor relationship, this neighbor would be created. I can use that loopback as a neighbor. So probably when we do this on this one JNS3, so this because that will not supported by here in Cisco Packet Tracer. So that will be, so when we do something called BGP concept, so there I will show you that we use something like that address for the neighbor relationship. So to do that, it's very simple. So configuration mode, and I will just say loopback, and I will give it some name, enter, and I'll just assign an IP address to it. Okay, it is 30 dot something, enter. So is what is giving here, this address is overlapping with loopback 0 because I already created loopback 0, and the same address I am giving to a loopback 3. So then that is an overlap. Obviously, it is an overlap, right? So and then exactly to create a loopback address, it's very simple. And creating an interface, virtual interface loopback, and a 3. Okay, and I'll give an IP address from this network that creates a virtual interface on that network. Okay, so to verify it, so you can see show IP interface read. show IP interface. So there you could see here loopback 3 is created and the IP address is assigned and is up and running. And loopback 3 is also created, but I have not assigned an IP address because that what is the IP address I assigned, it's get overlapping with loopback 0. Okay. To remove that, just no interface loopback 3, that's it. So that will remove that loopback which I created earlier. Okay. If I give that command again, loopback 3 is no more there. Okay. Similarly, I'll just do no interface tunnel 1, 2. That will also remove. I can just verify. So the tunnel is also not there. Okay, just like your IP address and all these things. Your interfaces, physical interfaces, and one virtual interface, and that with 30 dot. Is that clear, Karthik?
Yes, sir.
Okay. Okay, because since instead of creating the whole network here, I can simply create this loopback address, and I'm assuming this would be in one LAN.
Yes,
Okay.
sir. Got it, sir.
Okay. So if I want to check the route, which is the routing protocol, which is up and running on this router, I just wanted to give this a command. So when we use a do, when you are in global configuration mode, so always you should use before giving any command, show ipconfig, do have to use. Okay, but if you are in a privilege mode, like just hash, then you can simply give the direct command itself. So show IP protocol. Okay, show IP protocol it will give this information. But if you are in global configuration mode, means router config something hash, then this command is not work. Show IP protocol. Okay, that's invalid. So to work the same protocol there in the global, should use do. That's it. And this would same for every other commands. So whatever the commands that you use in privilege mode, if you are using that same command in a global configuration mode, then you must use do starting, then the command followed by the command. Okay. So what I will do now, I'll just remove this whatever the configuration I did on this part. Or else what I will do, I'll just do one more changes for the same network. I'll just remove this. I'll just delete this. I'll delete this. Okay. Then I'll connect a connection from this to this. I have no. Okay, and I will remove this one also. Okay, and I will connect from here to here. Okay, and I'll just connect one more from here to here. Okay, there is no space, right? Okay, no issues. I'll just open this. Before you turning on that, you just write this configuration twins. I'll turn off this and I'll add one line card, which is this one is fiber. Okay. Two. Okay. 4 Ethernet ports. Okay, I'm saving this configuration by giving a command write command, and I just add 4 Ethernet ports to connect it. Okay, and I'll just turn on it. So now I'll just connect this, and this. So because to check, or what I will do is I will just remove this, and I will show you how this Edge API will support a default load balancing. Okay. Am I audible?
Yes, sir.
Okay. Uh, I just connected in this way, ring topology, right? And I just configure this CHRP on this router. Okay. So I'll just do on one router and the same configuration on every other router we should do. Okay. I'll show you how to do it on one. So just the same way what how we did the RIP or OSPF router EHRP followed by the autonomous system number. And when you're giving this autonomous system number, you should give the same autonomous system number to all on every routers where you configure this EHRP. Okay, so once that you are just advertising every networks. Okay, so every networks which is connected locally connected to that router. 13 is connected and similarly 14 is connected. Okay, and the loopback address is 40. Okay, then that's it. Exit. And the same way I just did on this router also. So you can check here on this command by using this do show IP protocol. Just go. So EHRP is autonomous system is 11 and two networks are advertised, but I need to advertise one more network, which is this network. Okay, so I'll just go back and I'll just say EHRP 11 and I'll just advertise this network also, which is 14.0.0.0. Okay, to check some information IP, some here show IP, EHRP neighbor. Okay, here you can see for this router who are the neighbors. So one is this, and another one is this. Okay, that you can see here. Okay, so 11.2 is this one, and 14.01 is this one. Okay, and here also you can check the interface name and the times and RTO, round trip timers, counts, sequence number, and everything. Okay, and one more command you could also give here. So instead of neighbor, you just say topology. So you'll get some more information. Okay, so for this network, there is only one successor, and there is something like this. Okay, but the thing you should observe here is here, which I highlighted for 30.0.0.0 network. I have two successor, and you could see the FD value is 131072, and that would be the same for both of them. Okay, so which is 11.0.02 and 14.0.0.1. Okay, the two successor means there are two primary paths. Successor means primary path. Feasible successor means secondary path. Okay, so there are two successor. So then the two successor means have two primary paths. So means if I check the routing table, so we'll just show IP route. I think I would see two primary paths, two routes to that proper network. So just here, I think you see here there are two routes for this one particular network, which is 30 dot network. You can see here 30 dot network is where here. So that loop packet is here. This on this router I'm checking routing table. How this router can forward a package to 30 dot network? There are two paths. One is this way and another one is this way, isn't it? So that's where you can refer here. 30 dot network. I have two. One is via 11.0.0.2 and another one is 14.0.0.1. Okay. So we'll just verify this. So by doing this simulation method, okay, here you can see whether it is successful or not. Failed. Okay, we'll do one more time, and so again it failed sometime. Successful, right? So we'll do one more time. Okay, so then I'll check this in simulation mode. I'll just go to simulation mode and I'll just do capture and forward. Okay, see one sent on this link, and probably that would comes. Okay, and another, sorry, see similarly. Okay, EHRP advertisement. Okay, otherwise what I will do, I'll edit filter, I'll remove all these things. And let it be. Okay, I'll delete it and I will create one more time. Okay, capture and forward. So first it's sent on this way 11.0.0.2, and that is the IP address of the here, and sent to a destination, and it will come back with the replay. So for the next, okay, so it is something it sent and received. Okay, it's not an issue. But if you have a network here, a physical computer, then you might see the way it should forwarded here and as well here. Or else I can also do it. So I'll just show in real time. Okay, so I'll just show you here. I go to this router CLI prompt, and I'll exit from this. I'll be into privilege mode, and I'll just do trace route, trace RT, and followed by the destination address. Okay, so the destination address is this one, and I'm tracing the route how the packet has flowed, right? Trace RT. Any spelling is mistake? marker. Okay. It's not recognized. Place route followed by that destination address. If I give this, I think you see. So one packet is sent on 4.0.1 via this way. Okay, and other packet which is coming from 12.0.0.2, which is this way. Okay, so means you would understand. Uh, so the packets are flowing on both the way. Otherwise, you just look at this one. It's enough. Uh, show IP route. Okay, do show, not show, do show. Show IP routes. So here you can see. So there will be a uh, two routes for this 30 network. Okay. So, and the same thing that what I said, you can verify here. There are two successor. Okay. One is this one, and another one is this one. So means in topology table, when you are calculating this primary path, along with that, it would also calculate the secondary path. Okay. So it's only when this something a feasibility condition is satisfied. Okay, so feasibility condition in EHRP. Okay, what it is. So means if the primary links fails, okay, if any one of those link fails, it automatically send a packets on another link. So what I will do right now, so I will going to change a bandwidth on one link. Okay, let us say which is gigabit Ethernet 0/0/1, which is this one. So then I will check whether we would having the both primary and both primary path to this network. So what I will do is going to change this bandwidth on this network, on this router. Okay. So just go to configuration terminal and I'll just do show IP. Sorry, to show interface gigabit 0/0/1. So the bandwidth is default 1 GB. Okay. So I'll change that to okay. For that I have to get into that interface. So /1 and I'll say bandwidth. It's in terms of, actually this would be in terms of kilobits. Okay. Kilobits means I'll just change this something. Okay, once you changed the bandwidth, it's new adjacency, it's up and running now. Okay, I think now if I check, it's not going to have two primary paths to that network. The cost will change. There will be no equal cost. Then it doesn't do the load balancing. Okay, so to check that, show IP. What is that? EHRP topology. Probably, I think you see now it only has one success arm. Okay, isn't it? But we have both the entries here. Means that you should understand one would be, and also you can see here the FD value is changed, right? Now it is changed to 15. Earlier this would be the both were same, and is now 15.4.112. Means since the bandwidth has changed, it recalculate the every whole thing cost, and the feasible distance is this one, and if you check this routing table now, probably you don't have two route for that particular network. Okay, so if I do that, you can see now I would have only one route, and what I could see here is this will be your feasible successor. Okay, the feasible successor means, okay, if this primary link fails, okay, Okay, automatically it will take this routes and it will get installed over here. Okay, in the routing table. Means it doesn't again redo this EHRP protocol running. It doesn't run this algorithm. Soon, automatically, it will take this route, the feasible successor, and it will start forwarding that packet over that link. So what I will do to do this demonstration, I'll just manually shut down this link, just 0.0.0. And the changes you can see in this routing table. You just for that you should keep that in mind. So we have now for this 30 dot network and it's via 11.0.0.2 means this one this way because this is 11 dot network. If I shut down this link, immediately you can see the changes in the routing table on this via. Okay, because that it's already there in my topology table and which is the best path feasible successor to that network because we have more than one route to that proper destination. Okay, so what I will do, I'll just uh, intentionally I'm shutdowning that port which is 0.0.0. Okay, it doesn't affect. Okay, you can see here the changes also. This link should shut down. Sorry, I went to that right. I'll just give this command, no shutdown. Instead, I'll just give this shutdown. Okay, means it shut down the port. You can see it turns to red, right? Okay, so now if I check show IP route, okay, I'll maximize. You can see now the same D which is 30 dot. I have the route to reach still, and that is via 11.0.0.1. Okay, and if I check the same thing, show IP EHRP topology, I think for that I have only one successor, and this is only a link. I don't have any feasible successor because that link is down right now. And if I turn it on again, if I turn that no shutdown, okay, it's up and running, and now you can check it comes back to the it's come back to its original data 11.0.0.2. And if you check the same thing for topology table, GRP topology, you could see now two successors are there for because this is two, not two two successor means when the equal it has a equal cost. Here we have a two entries means you should understand it has two paths. And the same thing for 40 dot network also we have two paths. One is via 11.02 and one is via 40 dot network where it is the 40 dot network is here. One is this way and another one is this way. It has also two paths. Okay, that you can verify over here. Okay, is that clear?
Yes, sir.
Hello, Bhavana. Rohit. Okay. So how this what you call FD and AD value? So the thing here, what you saw 12618 is something what we call feasible distance. The first value is tells feasible distance, and the second value tells the advertised distance. Okay. So what actually it means? Okay. So feasible distance is nothing but I will explain here itself. For the sake of example, you just assume it right. This the cost of this is 100, Okay, and the cost of this would also 100, and cost of this would also 100, and the cost of this is also 100. And this is your source and this is your destination. Okay, this is your destination and this is your source. So FD is nothing but feasible distance. Means the cost from source to a destination is nothing but feasible distance. So what is the cost? There are two routes. Okay. So one is, let us, if I call this as A, B, C, and D, to reach this destination network. Okay. So I have two routes. One is ABC, A, B, C, and another one is A, T, C, isn't it? So the feasible distance for the both route is the total cost from a source to destination. What is the feasible distance from this route ABC is 200, right? 100 plus 100, the total cost. So, and the same for this route, what is the feasible distance? And it is also the same. The feasible distance is 200. So then the another one, we have something called AD value, right? Advertised distance means it is the cost from the neighbor to the destination. Okay, so means because this on this route for the destination, which actually the information is advertised by this router to A, right? So that is what we call advertised distance. Advertised because from here the router B is sending advertising on this destination network to the A. Okay, for A the source is from B, and the cost from B to destination is what we call advertised distance. So when it is advertised, along with that cost, it adds this its own cost, link cost to its routing table. That is what the total feasible cost. Okay. So then the advertised distance is it's from the neighbor to the destination. So then is what is advertised distance is 100. Then what is advertised distance from this route? Can anyone tell? So what is the advertised distance for this route? A, D, C. It is a cost from neighbor to the destination, right? So what is the advertised distance?
100 itself.
100. Okay. If I lightly change this 200 and this is 400, can anyone tell what is the feasible distance for a route ADC?
600.
Huh? It's 600, and what is the advertised distance?
200.
And that is 200. Okay. Is this understood? So when you are running any AHRP protocol on any router, so these two terminologies are very important. What is FD value and what is AD value? So that is what you are seeing here. Here. So FD is this, which is 128256. Okay, and here you'll get both the things. So FD comma here you'll go back to the FD is 3072, FD is 3072, and 2168 is the AD value. This is advertised distance. If you neglect these two, means if you minus from 3072 with this thing, you will get the cost between those two neighbors. Okay. Okay. What is the feasibility condition? Why we need this feasibility condition is so when a router, this AHRP is calculating the feasible successor. Secondary part, this feasibility condition should be satisfied. So what is the feasibility condition? Okay, the feasibility condition is okay. The feasibility condition is this. Okay, the feasibility. You just write it properly. Feasibility condition is okay. The feasibility condition. Okay, the current successor. Okay, current successor FD value. Current successor FD value should be greater than AD value of feasible successor. This is the feasibility condition. AD value of feasible successor means secondary path. the FD value of primary path or best path in the category should be greater than the AD value of secondary path. So that is the feasibility condition. If this is satisfied, then it will calculate the secondary path. Otherwise, if this feasibility condition is not satisfied, then it will not calculate the secondary best path. So then what will happen? Then again, it will send a query message to all neighbors to get back the information about that particular destination network. Okay. The feasibility condition is this. The FD value of the primary path should be greater than the AD value of the feasible successor. Okay. Since these two having a same, because if I look at here now, okay, but you can take this one. Okay, this as an example, 100, 100. Here it is 400. Here it is 200. So what is the FD value for the first ABC? It is 200, and the AD value is 100, and for ADC it is 600 and 200. Whether this satisfies the feasibility condition? Whether it is satisfy the feasibility condition?
Yes, sir.
How? It doesn't follow is right. See, this should be, sorry, it's not right. Okay, this is a primary path now, right? ABC is a primary path because it has a least cost. Okay, 200. FD value is 200. Here it is 600. So this would be primary path. The FD value of the successor, current successor, should be greater than the AD value of the feasible successor. Feasible successor is this one. The second path is this one next, right? But the AD value is 200. It is not, the condition is greater than or equals to. This FD value should be greater than AD value of feasible successor. Then this feasibility condition is not satisfied. So then it will not calculate this to as a secondary path. So if this any links fails, again this outer is going to send a query message to a neighbor, and this would send a query message and it will get the complete information. So then after it will learn and find this route to forward the packet. Okay, when this feasibility condition is satisfied, why? Because because if you look at here, my feasible distance of a successor, okay, so itself is greater than the AD value of the feasible successor. Okay, if what happens if this would be in 250, so the router would thinks my FD value itself is least than the AD value of the second feasible successor, then probably it would be a kind of looping in a network. Okay, looping in a network means so it will go here again. It would be coming back to me with 50 more cost. This router would think, so it will coming back to me itself in 50. So then in this scenario, it will not going to calculate the secondary best path. Okay, so it will, so this, the way in which it send a query message, we call it as stuck in active scenario in EHRP. Stuck in active means it doesn't able to calculate the feasible successor. This situation of that router, what we call stuck in active. It will send a query message again, and it will do everything, the EHRP process, complete process. Then after that, it will forward the packets to a destination. Is this clear or any doubts?
Yes, sir.
Okay, from others? I just want response from each one of you. Ajay, Pooja. Hitesh, yeah. So, okay. So what I explained so far, you do that. Okay. You just do the DHRP for this diagram. So probably in the next class, I will explain the DHCP with relay agent and how you configure VPN, because the VPN is one of the important concepts, because once you get into any of the companies, once you offer with any companies which you get placed here, so they will ask you to connect to the network through VPN. So by that time, you should not be very aware. You should not be unknowing about that what is VPN, how to connect it, and so on. So that's why I have one class dedicated to that, to explain about what is VPN, the type of VPN, and so how to. So we'll understand how the basic things, how this VPN will work. Is one type of WAN connection. Okay, I think you might have understood the frame relay or ATM kind of or MPLS kind of WAN connection. So this is also the same way we would connect from your network to another network. So we have different types of VPN networks. One is site-to-site VPN or remote access VPN. I think you might have known if any one of the person from your relations working with some companies and they are connecting their network from there to their company's network. There is something we call the type of connection is remote access VPN type of connection. Okay, so all these things we will discuss in the next class. Along with that, we will also look at how the DHCP with multiple broadcast domain by using that relay agent concept. Okay, so we will look at that, because so we will looking at each this concept individually, but in your exam probably all this concept will comes to one network, so that which will be gives more understanding how this typical a network would be designed, how this would be configured. And all. Okay, because when we include this switching concept, VLAN concept also, which will give us a better understanding of how this a network which will be designed for any typical organizations. Okay, so along with this, for the next lab, so with this EAGRP and understanding each one of them, and also you should explain this in clear to an faculties who are in charge to your lab. Okay, because I am getting a feedback that they were not knowing even a simple concept like subnetting or whatever the demonstration that you've given so far. Okay, that should not be heard by me for the next time. Make sure that, because each and every lab will be evaluated, right? You should be very careful when you are demonstrating, and you should also uh, properly answer the questions asked by faculty. I don't know what is the reason it's happening. If that is from my side, I always welcome to give feedback, so that I'll just tune my the way which to explain this concept. I just want some feedback from you, whether you are understanding or want to change the way which I am explaining. Anyone would like to give any feedback or something? Ian Raw, Karthik, Ajay, Priyanka, Charan, Sayed, Pooja, Shit, Rohit.
No specific, sir.
Uh-huh.
No, sir.
Sayed, ಅಲ್ಲ ಅರ್ಥ ಆಗ್ತಿದೆಯಾ ಏನ್ರಪ್ಪ? Then why your performance is not good in lab time? Karthik choice.
Yes, sir.
So I'm asking the question is, so why your performance is not good at when any faculty, like when you are performing this demonstration under faculty in charge? So they were giving a very poor performance feedback. So that I'm not asking you, but I'm asking in general.